A very good evening to one and all present here, guys. I welcome you all to the session. I believe everything has been fine and everything's been going around good. Yeah, very good evening, Mama Sun. Okay, so let us get started with our sessions. So today we basically were working with multiple linear regression, right? So let's just get started with this multiple linear regression. Okay, so I have already shared you this data. Okay, and yeah, we were basically getting an error of 1.23, right, guys? So this was the error what we actually received. So let us just load the data once and let us work on this. Advertising.csv. So this is the data set what we have, and let me just run this up once more. And yeah, so basically the mean absolute error what we are getting from here is 1.2363, right, guys? So this is the error what we get. But now, guys, how would we know that all these three variables are important for our model? Okay, so how can we understand that all these three variables are important, and what do we do basically to figure out whether it is important or not? So what we can do is, guys, we can go with different features one at one time. But before going with trial and iteration method, which one has to be chosen first? Who would decide that? That will be decided by something called as correlation. What does the correlation means by? The correlation means, let's say you have x1, x2, x3, x4, and then y. So how this x1 is related to x2, how this x1 is related to x3, then x4, and finally how is it related to y? Okay, like what is the relation between these two objects? Like let's say, for example, I'm talking about x1. So whenever the value in x1 basically changes, the value in y also changes. It's not necessary that it has to be the same value, but the value actually changes in the same manner. Like if it is increasing, then this also increases. If this decreases, then this value also decreases. That is called as correlation. Like what is the relation between this column and this column with respect to? So if the value is increasing here, the value also increases here. That is called as correlation. So we need to find out the correlation between these features and your label. So here the label is sales, features are these three things, right? So that is what we need to figure it out. So how do we do that? This can be done by using df.correlation. Okay, so we basically have to use with df.correlation. The method what we are using is Pearson method. Okay, so the by default one basically, and this is what the correlation you have. So for TV, yeah, you can check that the correlation with TV is obviously 1, because obviously it is correlated. I mean that doesn't make any sense. But here, guys, we are not trying to find out what is the relation between x1 and x2, x3, but our main area of focus is the sales column, like how this input is dependent on sales. So here you can see it's 90%, like positive 90% sale. So that means if there is a change in data in TV, then there is a 90% chance that even in the sales, the data will be varied according to the data what you have changed in TV. So if you have given some more amount, if you have spent some more amount on TV, we need to understand that 90% of there are 90% chance that even the sales will go up. Or if you reduce the number of amount in TV advertisements, then the number of sales amount for the 90%, there is a chance that it will go down. That is meant by 90%. I mean, sorry, that is meant by correlation. So here 90% TV is correlated with sales. So which is the strongest feature? So we are going to consider that for sure. The second one is radio. How radio is correlated with sales? 35%. So 35% is also a good correlation actually, guys. So we are going to consider that. The third one is newspaper, and the correlation what we have is plus 16%. We'll check whether do we have to consider this or not. Okay. So how do you do that, guys? Basically, we run all the different inputs now. Okay. So how do we run the inputs, guys? First of all, we are considering TV because TV is very important, right? So what I'm going to write is I'm going to write it as x of TV. Okay, x of TV is equal to df.ilog of all the rows and zeroth column dot values dot reshape. Why reshape? Because there we have only one variable, that is TV, right? Zeroth column is a TVth column, so zeroth column, that is your TV. So you have x TV now. Okay, now if you have to run this model, what you have to do is you have to go with lin dot fit. You have to fit the model, right? So lin dot fit basically, you have to give x and y, right? So instead of x variable, you have to go with x TV, and y would be y. Obviously, there is no doubt in it. So let's run it. So our model is ready. Now, if you want to predict it, then you have to run the predict method. And what is the predict method here? X underscore TV. That is the predict method, right? And here I'm going to call it as y TV. Yeah, y TV is basically y pred value of x with TV. That is what we have. Now, if you want to calculate the error, what do? We have to import MAE. Have we done that already above? Have we done that already? Let me check. Okay, as MAE, let me call it as M. Okay, so MAE, you have MAE. And what else do you have? You have y true and y pred. So what is y true? Y true is nothing but your original y, whatever you have. And along with that, what is your pred y for TV? That is y TV. So let's run it and check the error. Yes, you are getting a huge error. This is 1.83. Earlier, you were getting 1.23. But now, alone with TV, even though you just saw that there's a 90% chance that, I mean, 90% correlated. It is correlated with 90%. And you basically saw that how exactly it behaved. Like you're getting a good marginal error, like 0.6 is a lot of error here in this case, right? So yeah, you're getting an error here. Okay, 1.83. So we cannot go alone with TV. So what else? What is the next thing we do? We basically add another variable, that is TV and radio. So I'm going to call that variable as x underscore TVR because it contains TV and radio both. So df.iloc, all the rows and columns, it will start from 0, it will end up with 1, right? But iloc, this is exclusive. So that's why we'll go with 2. And here we don't have to reshape because it will be already in 2D, right? So we don't have to reshape this. So xtvr is done. Now lin, again, lin.fit method. And what are we going to fit here? X underscore TVR with respect to y. So run this and there you go. So now you need ytvr, and that you are going to get it from lin.predict option. And here you basically have x underscore tvr. So that is your ytvr. And finally, what is the last thing we need to do? We have to calculate the error now. That is mean absolute error. So that is y against ytvr. Run it, and then you can see, guys, now the error is 1.2367. 1.2367, and here with all three, what was the error? 1.23639. 1.23639, right? 1.236, 639 here, 67. That is, this error is 0.0004. There is an increment of 0.004 value in this error. So what can we conclude by this, guys? With all three features, you are getting an error of 1.2363, and with all, I mean, only two features, you are getting an error of 1.2367, right? So we can come to a conclusion that to make our model more dependent, there is no requirement of newspaper at all, because all the job can be done by using TV and radio itself. There is no role of newspaper affecting that much in our model. So what we can do is we can suggest our clients that there is no need to invest in newspaper. Instead of that amount, you can either invest it on TV or in radio. So you are basically going to get much more benefit if you do in that direction, if you go with that option. So this is how you basically calculate the error and you optimize your error. This is one of the method how you can optimize the error by selecting a correct features. Instead of selecting all the features, you just select a specific feature and then you can basically optimize the error, guys. Okay, so this is one of the methods what we are going to, we basically use it. So whenever we have multiple linear regression problem statement, this is what we basically do. Okay, so if you have any issues or any concerns with this, you can just let me know. Yeah, if you have any doubts until here, you can just ask me. Otherwise, we shall start with the next problem statement. Yes, lin score actually tells you the accuracy, like how accurate your model is. So here, if you want to compare x and y, yeah, 90% accurate. Okay, you could have checked out for other options as well, but now if you check it, it's not going to give you a proper output because the lin is basically trained on the basis of xtvr, right? So don't go for any other options. If you had to do that, you have to do this earlier. Okay, yeah, let's just proceed further. That's what we did. That's what we did as of now, Nayan. We basically selected a proper feature. Instead of selecting all the features, we just selected a proper feature. This is one thing what we can do. And there are other methods also, Nayan, which we'll see it later. Okay. Okay. Now let us understand some other problem statement here. Now, guys, as you know, the equation for a simple linear regression was y is equal to b naught plus b1 x1. We have already seen this stuff, right? But the equation for multiple linear regression is y is equal to b naught plus b1 x1 plus b2 x2, and it goes until bn xn. Yeah. So this is how the equation for multiple linear regression looks like. Okay. Now, guys, the whole point is, let's say we have to calculate the, let's say this is the problem statement, like these are the ages of the people, and at the same time, you also have whether are they vaccinated or not. Okay, so have they taken the vaccine or not? So let's say for age 0, the vaccine is 0. For age 10, the vaccine is 0. 15, it's 0. 20, it's 0. 22, it's 1. 25, it's 0. 27, it's 1. 30, it's again 0. Okay, and then 32, it's 1. And then 39, it's 1. 45, 42, it's 1. Okay, 43, 0. So something like that, guys. So this is what the data set what we have. Okay, now the data set what we have is in age and vaccine. So basically whether this person have taken the vaccine or not. So depending on the age, we need to decide. Okay, so my now the next thing what we need to do is, what if I want to visualize this data or I want to plot this data? Then how can we plot this data? Let's say this is your age column and this is your vaccine column. This is your vaccine column and then this is your age column. Okay. Now, guys, if you want to plot the data, then it has to be 0 and 1. Correct, guys? This is 0, this is 1. So according to the data, if you want to plot it, let's say the data would look something like this. Yeah, this is what the data would look like. Okay, so this is how our data would look like. So this is, let's say the age is 10 here, this is 20, this is 30, this is 40, this is 50, and this is 60. So this is what the data looks like. Okay, here, can we solve this problem by using linear regression technique? Can we solve this problem by using linear regression technique, guys? Yeah, my question is, can we use this by using linear regression technique? Yes, the answer is, see, directly we cannot use linear regression here. Okay, directly we cannot use linear regression here, but we have to modify our linear regression technique into logistic regression, and then we will be able to solve this. So first of all, what problem is this, guys? Is this a classification problem or a regression problem? First, tell me that. Look at the output. Forget about all these things. Just look at the output. Like, what are we expecting here? What is the output? We are expecting whether they have taken a vaccination or not, right? 0 or 1, yes or no. So what problem is this? Yes, this is a pure classification problem. But now what we are going to see here is how to solve a classification problem by using a regression method. That is what we are going to see now. Did you get my point? We have to solve our classification problem by using the regression method. How? Let me discuss that. So let's say this is how the data looks like. And now what am I going to do is I'm going to draw a linear regression line over here. Let's say best fit line. So this is how my best fit line would look like. Okay, guys, the one what you're seeing on the screen. This is how my linear regression would look like. Now, the next thing what we do is, guys, the first thing what we do is we apply a function in such a way to our line here. Okay, we apply a function in such a way that if the value is less than 0, okay, if the value is less than 0, then we will make it 0. The condition is if the value is less than 0, that is these values, right? So if this value is less than 0, we will make it 0. And if the value is more than 1, we will make it 1. This is the function what we need to apply here. That if the value is less than 0, that is negative, we will keep it as 0. And if the value is more than 1 in our line of regression, we will keep it as 1. So if you modify that, then our data, this data will be overlapped over here. And then this will be overlapped over here. This will be gone. And this is how our data would look like. After applying this function, this is how our data would look like. But this is not going to help us in any way, right? But this is the step what we need to do. Now what we do is we take this equation and then we apply a sigmoid function onto this. We basically apply a sigmoid function onto our existing data, whatever the existing data we have, right? So that function we are going to apply here. And the sigmoid function what we are going to apply is basically given as p is equal to 1 by 1 plus e to the power of minus y. So this is the sigmoid function what we have to apply there. And the moment when we apply the sigmoid function, the final equation would basically look like ln of p by 1 minus, ln as in a natural log of p by 1 minus p is equal to b naught plus b1x, b1 x1. So this is the sigmoid function to our linear regression. This is how it's going to look like, and visually this is how the data would look like. Okay, so on the left axis, on the y-axis, instead of 0 to 1, now we will have the probability of 0 to 1. Okay, we will have a probability of 0 to 1, and then we had some data points here, right? Yeah, we had some data points here. So what we do is we basically, this is how our function will get transformed into our linear regression, whatever the linear regression line we had, right? So this line will be converted into this line, okay, with the help of our logistic function or a sigmoid function what we have applied here. Okay, so now guys, what we would do is we will use our regression technique. Okay, we will use our regression technique. So let me just write down the year here, 10, 20, 30, 40, 50, 60. So now you guys tell me, if the x value is 10, what is the y value? For x value is equal to 10, what is the y value, guys? What would be the value? This is a probability event now. So we are not going to have 0 or 1, but we can also write the probability values like 0 0.1, 0 0.12, 0 0.13, something like that. So for x is equal to 2, what is the probability here? A very low probability. Maybe we can write it as 0.1. Let's just say. Okay. Now for the value x is equal to 20. So where does the equation falls? Over here. That is 0.2. For x is equal to 0.3. I mean, sorry, x is equal to 30. What is the probability? Yeah, it lies here, and the probability would be 0.35, let's say. For 40, probability is 0.65 for 40. For 50, and for 60 it's 0.99, something like that. Okay, so this is how the probability looks like, whatever we have. Now we are asking a question and we are getting the response in terms of probability. So this is not a classification. Now we are getting an answer in regression. Okay, now what we do is we basically keep a threshold frequency, a threshold. Basically, like if the probability is less than this amount, we will give it as 0. In this case of vaccination, let's say that value is 0.5. That value is 0.5. So if the value is 0.5, now in our prediction now, if we are getting a probability of less than 0.5, anything 0.5 or less than 0.5, okay, 0.5 or less than 0.5, okay, then what are we getting? We are going to write it as 0. If it is more than 0.5, we are going to write it as 1. That is how we convert a regression into a classification problem. So in this first attempt, what is the value? 0. Here also 0. Here also 0. But here it will get converted into 1, 1, 1. So here you have got 0, 0, 0. Here you have got 1, 1, 1. This, my dear friends, is called as logistic regression. This is how logistic regression works. So basically, it is actually a classification problem, but we use the regression technique to solve our classification problem. This is one of that problem, I mean, one of the solution where we get both the stuff, like we get the regression output and the classification output as well. So this logistic regression is considered to be a very important algorithm in our machine learning and deep learning as well. It's not only alone for machine learning, guys, but also for deep learning. So this logistic regression is going to help us on a longer run. Okay, so this is how actually things work in your logistic regression. Okay, did you understand, guys, what exactly we did here? We just took a regression problem, we applied a logistic function. The moment when we applied a logistic function, the curve changed in this manner, and on the y-axis, instead of 0 to 1, we got a probability values, like what are the probability of a vaccination, whether is it 0 or a 1. So this is what we basically get here. Okay, understood, guys? If you have any doubts, any concerns, please let me know right away. Okay, guys, is it done? If you have any concerns, any doubts, please let me know. Okay, now let's proceed further and let's get started with this. Okay, so for this I might have to I have to give you another data set, guys. Yeah, I will need this July ML1, right? Yeah, so here I need to give another data set here, and this data set is social network ads. So just load the data set with social network ads. So let me create a new notebook. Did I give you this file? Yeah, this was yesterday's file, right? Okay. Yeah, we can go with logistic regression ads, and here we have to add that. Social network ads, right? Yeah. So this is how your data set looks like. Okay. So please load the data. Yeah. In the meanwhile, let me locate this file and let me give you this file in your drive folder. Aditya, for that you have to go to the LMS portal. Okay, you might have the moment when you have registered for the sessions. After that, you must have got an LMS portal link with your user ID and password. You basically have to go to that link and log in, and then all the recordings will be available there. Actually, I don't have the access, so I cannot show it to you. Okay, but it's definitely available in your LMS portal. Now, this is the file, right? So let's move it to our folder. Sorry guys, yeah, I just forgot. Okay, anyway, so now we basically have to work with this logistic regression. Now, guys, one thing what we need to understand is we basically have age and then salary here, gender, age, and salary, and then purchase column. So what we can basically make out from here is we basically need some features, and then what is the purchase column? Purchase column is going to be our output column. Okay. Sorry, yeah, I was on mute, right? I explained everything, but it's okay, no problem. So what I was telling you is, uh, this advertisement is basically for some car. Okay, for a car, basically. So there are some individual responses what you have got, like age and then salary. Okay, the age of a person, the salary of the person, and whether they have purchased this product or not. So that is what you basically yeah. So this is what you have with you. Okay. Okay, Aditya. Okay, Aditya, for that you have to contact our support team. Our support team would actually help you regarding this matter. Okay, so just connect with the support team. It's basically support@verzio.com. You just let them know and they will help you out with that. Okay, so yeah, as I was talking about this purchase column, guys. So these are the advertisement and these are the history of the people those who have purchased the car. Okay, so 0 means they didn't purchase, 1 means they did purchase. So after making a model, how this model is going to work, like guys, this model is going to work in this way. Okay, so just understand this. You just have to input any one of the features like male, age, and salary. Not anyone, all the three. Let's say male, age is 25, and salary is, let's say, 56,000. So just by entering this data, your client would understand whether this person would purchase the car or not. So it will be a better understanding for the clients, right? So they will target the marketing area in a very specific manner, right, guys? So this is how it's going to work like. Okay, so this is one, and this is basically you get to know, right? So this is what the model we are creating here. Okay, so if we basically have these features, you will get to know whether the person is going to purchase a car or not. So just to reduce the complexity of the equation, what I'm going to do is I'm going to take only age and salary as the input and purchase column as the output. Because here this is not string, this is not integer, this is string, right? So we have to convert it into integer. So this I'll explain you later. But as of now, let us consider that age and salary. Let us just consider age and salary here. Okay, and let's just build the model. Okay, so how can you build the model, guys? Just take age and salary as your input and purchase column as your output. Okay, just do that. I'll be there within a minute. Okay, so this is for the data frame you have. Out of this X, what I'm going to do is df dot ilog. Okay, all the rows first of all, and regarding the columns, what do we need? 0, 1, 2, 2 to 4, right? So 2 to 4 is the columns what I need for input dot values, and for Y, what is it for Y, guys? It will be only 4 for Y, right? Oh, sorry. This has to be Y. So this is Y, and okay, I have to run this again. So let me just cross verify, guys. X, how does X looks like? Yeah, the age and salary. So X looks good. How about Y? Y should be zeros and 1, right? Yeah, so we have zeros and 1s also over here. Now, what is the next thing we need to do, guys? What is the next thing we need to do? We basically have to train test split, right? So we have to train test the data here. So how do you do that? From sklearn, okay, dot model selection, okay, import train test split, okay. Yeah, train test split. So now you get this train test split done. Okay, so what do we need? X, we need X, we need Y, and then we need test size that is equal to 0 0.2, 0.3, whatever you want, you can give that, and then you require a random state is equal to 0. And then what else? X train, X test, then Y train, Y test. Run it. X train, X test, Y train, Y test. So this is what we need. Okay, so if you want to check it out, you can check it out. X test dot shape, because the moment when you give shape, you will understand how many values. So 80% of 80 values, 20% of 400 is 8, right? 80, sorry. So that's why 80, 2, because 2 features, right? So that's what you have. So your train test split is done. Now, what is the next thing, guys? What is the next thing we need to do? We have to get our logistic regression. So again, from sklearn dot linear model, import logistic regression. Okay. Classifier is equal to, I mean, you have to declare your classifier here. I'm going to write it as log. Instead of lin, I'm going to write it as log. And what do I have? Logistic regression. Okay, I need to run this first. Then only I'll be able to get this. Okay, so now we have to fit the data. That is log dot fit. You have X train, and then you have Y train here. X train, Y train is the data what we need to train here, and our model is done. And finally, what do we need? We need predict, log dot predict. So what are we predicting? We are predicting X test. So this is what we are going to get, and this X test is nothing but your Y pred value. Okay, now to calculate the error here, guys, we need to take accuracy. Okay, we need to get accuracy here. So it's the same similar thing, but from sklearn dot metrics, import accuracy score. It is called as accuracy score. So accuracy score you have to give here. So if you take your accuracy score, guys, or let us just see Y pred first of all, before even going for accuracy score, just check your Y pred, and this is your Y test. So do you see a problem here, guys? Do you see a problem here with your Y pred and Y test? What is the problem? Yes, everything is 0, whatever you have there, right? Everything is basically, yes, everything whatever you have there is of 0 basically. That is why it's actually an issue, whatever you have there, right? That is actually an issue. So how do we solve this problem? We solve this problem by using some other technique. So what is that technique, guys? We will see that in our next session. Okay, so we'll see this technique, how to, like, what is the issue and why are we getting this? We'll see that in the next session. Okay, so fine then, guys. Thank you so much. We'll see you in the next session then. Okay, fine. And yeah, today's class was until 9 o'clock only because I have some work I need to leave. Okay, so I'll see you in the next session, that is on Tuesday, right? Fine then. Thank you, guys. Thank you so much. I have already given you this data. You can just go through it, and in the next session I'll explain you what exactly we did wrong here. Okay, so I'll explain you in the next session. Okay, fine then. Thank you, guys. Thank you so much. We'll see you in the next session then. Okay. Yes, I'll upload some more data sets for the practice. For linear regression, yes, for linear regression, I'm going to provide you more data sets. Okay. So fine then. Thank you, guys. Thank you so much. We'll see you in the next session. Okay. Bye-bye, guys. Bye-bye.